Hello everyone, welcome back to my Cellchat video tutorial. In video 6, we merged the Cellchat object for normal skin NL and injured skin LS, and also we made an object list for both objects. So in this video tutorial, we can use the Cellchat and the object list to compare the difference of cell-cell communication between normal skin and injured skin. So we don't need the individual object anymore, so we can remove the NL and the LS object. We just need to keep the Cellchat and the object list for today's demonstration. We already know there are 42 signaling pathways in the NL object and 47 signaling pathways in the LS object. They were saved in the NetP data slot. So we can compare the overall information flow for each signaling pathway between NL and LS object. So we can use the rankNet function to see the information flow for each signaling pathway. Let's zoom in. So you can see red color labels the information flow for signaling pathways in the NL object, and blue labels signaling pathways in the LS object. So in total, there are 48 signaling pathways in both objects. You can see the PTN signaling pathway is only identified in the NL object. And down here, 6 signaling pathways MPR2 to BAFF are only identified in the LS object. There are 41 signaling pathways presented in both objects. You can see from the relative information flow, IL6 and SAM3 signaling pathways almost 50-50 in both objects. Up here, the signaling pathways are stronger in the NL object, and down here, the signaling pathways are stronger in the LS object. So this figure shows stacked information flow. If you prefer to compare each signaling pathways side by side between NL and LS object, you can set the stacked argument as false. Then we can plot the information flow again. Let's zoom in. You can see now each signaling pathways are presented side by side for NL and LS object. You can see strong activation of signaling pathways in the LS object, CXCL, connecting L2, MIF, L4, and the signaling pathways down here are only activated in the LS object. So we compared the information flow for each signaling pathway. Then next we can compare the total number of interactions and the interaction strengths between NL and the LS object. So first we can compare the total numbers. We merge the NL and LS object into one Cellchat object. So there are two groups in the Cellchat object. Group 1 is NL and group 2 is LS. So we can compare the total count for each group. Let's run this function. You can see in the NL group, the total count is 2,697. But in the LS group, the total count is more than 5,000. So you can clearly see the difference of the total number of interactions between the NL and LS group. And also we can use the same function to compare the interaction strengths. So now you can see the interaction strength for the NL group is around 4, and the interaction strength for LS group is above 7. So next we can use the scatter plot to compare the outgoing and the incoming interaction strengths for all the cell types. Because we have 2 groups in the Cellchat object, and you already see the total count is much higher in the LS group. In order to compare the count on the same scale between NL and LS group, so we need to set the maximum and the minimum number of counts. So first we can get the total count for each cell types in both groups. So you can see we named as the count sum. If we click the object, you can see here is the total count for each cell type in NL group and LS group. From here you can see the lowest total count is 0 in the NL group, and the highest count is 1381 in the LS group. So we can set the minimum and the maximum weight to control the dot size in the scatter plot. If we set the weight minimum and the maximum, you can see the minimum is 0 and the maximum is 1381. So now we can make a list to plot both groups. So we have 2 groups, NL and LS group, in the Cellchat object. So we can use the scatter plot to plot the outgoing and the incoming strengths for each group. So now we can use the wrap plot function in the patchwork package to plot the scatter plot for NL group and the LS group side by side. Okay, so the plot windows is too small. Let's make it bigger. We can plot it again, and we can zoom in. You can see now the incoming interaction strength is on the y-axis, and the outgoing interaction strength is on the x-axis for both groups, NL on the left and the LS on the right. And also, we set the same scale for the dot size to show the total count in each cell group. You can clearly see the difference for the dot size for each cell group, and the dot size are much bigger in the LS group. And also you can see the outgoing interaction strength. Most cell groups are below 0.5 in the NL group, but in the LS group they are bigger than 0.5. So here we show the incoming and outgoing strengths for all the cell groups. You can also use the scatter plot to plot the signaling pathways in individual cell groups. So let's use the inflammatory dendritic cells as an example to show the incoming and outgoing strength and also the count. So we just need to set the identity use as inflammatory dendritic cells. Then we will generate a scatter plot for signaling pathways in inflammatory dendritic cells. So you can see the differential incoming and outgoing interaction strengths. Compare the LS group to the NL group. You can see the upregulation of signaling pathways here. Because we know the MIF signaling pathway contributes the most to all the signaling pathways. So here, the MIF signaling pathways shows high differential incoming and outgoing strengths. But it is very hard to see other signaling pathways down here. We can exclude the MIF signaling pathway to see other signaling pathways. So let's set the signaling exclude argument as MIF. We can plot it again. You can see now we don't have the MIF signaling pathway. Then you can see other signaling pathways that are differentially upregulated in the LS group. You can see CXCL pathway, CCL, L2, L4, connecting complement signaling pathways. They are upregulated in the LS group. So next I'm going to show you how to use the circle plot to compare the difference between the NL and the LS group. First we can use the circle plot to show the number of interactions between any two cell groups. Like the scatter plot, we are going to compare the interactions between NL and LS group side by side. So like the scatter plot, we can get the maximum weight for the cell numbers and also the count for both groups. Then we can set the same scale to make it comparable between both plots for the dot size and also for the width of the arrows. So you can see here the value for the weight max. Among all the cell groups, the highest cell number is 1228. And the highest count between any two cell groups is 95. So now we can plot the interaction numbers for the NL and the LS group. We set the plotter parameter to plot them side by side. So now we can zoom in. You can see the number of interactions for the NL group on the left hand side and the number of interactions for the LS group on the right hand side. The arrows show the interactions between any two cell groups. You can see in the NL group, there is no interaction for the dendritic cells type 1 and also the inflammatory dendritic cells. But there are more interactions between any two cell types in the LS group. So here we show the interactions between any two cell types for all the signaling pathways. It looks very complicated for the figure. If you are interested in certain signaling pathways, you can just plot the signaling pathway that you are interested in. So we can use the CXCL as an example to plot individual signaling pathways. Once again, we need to get the maximum weight for the CXCL signaling pathway. Then we can make it comparable between NS and LS group. So you can see now the maximum weight for the CXCL group is set as 0.0494. Now we can set the plot parameter again. Then plot the number of interactions for the CXCL signaling pathways between NL and the LS group. So let's zoom in to see the CXCL signaling pathway. Now you can see the plot show the interactions between any two cell types in the NL group and also the LS group for the CXCL signaling pathway. From the information flow chart, I showed you there are 41 signaling pathways presented in both NL and LS group. So here we just use the CXCL as an example. You can try other signaling pathways. Here we plot the total interaction numbers for any two cell types in the NL and the LS group. We also can calculate the differential numbers between LS and the NL group. For this calculation, we can use the net viewer differential function in the Cellchat package. So first, let's set the parameter for plot two figures together. We are going to plot a differential count and also the differential weight. That's the interaction strength between the NL and the LS group. So let's plot the differential count on the left, then the differential weight on the right. So we can zoom in to see the figures. You can see on the left hand side are the differential numbers of interaction compared the LS group to the NL group. The red arrows show upregulation and the blue arrows show downregulation. And on the right hand side is the plot for the differential interaction strength. Once again, the red arrows show upregulated strength in the LS group and the blue arrows show downregulated strength for the signaling pathways compared between LS and the NL group. You know we have 12 cell types in both groups. So far we use the circle plot to plot the interaction strength between all the cell types. Once again, the figure looks very complicated. We can combine the cell types, for example, all the fibroblasts, all the T cells and the dendritic cells, then to simplify the figure. So let's group the cells into fibroblast, dendritic cells and T cells. Then we need to merge the interactions to 3 cell types and merge the cell chart again. Now we need to get the maximum weight for the merged cell chart object. So we are ready to make the plots again to show the interactions, but now we only have 3 cell types: fibroblast, dendritic cells and T cells. Again, we set the parameter to plot the NS and the LS group side by side. First, we can plot the interaction numbers for the NL and the LS group. Let's zoom in again. You can see now we only have 3 cell types: fibroblast, dendritic cells and T cells. On the left hand side is the plot for the NL group and on the right hand side is the plot for the LS group. You can see the difference of the width of the arrows, and also we indicated the interaction numbers between 2 cell groups. You can see the width for the arrows is much wider in the LS group, and also you can see the interaction numbers are bigger in the LS group. Here we show the total interaction numbers like we did before. We can also show the differential interactions between the LS and the NL group, and also for the interaction strengths between NL and the LS group. We will plot them side by side again. So first is the differential numbers. Next will be the differential interaction strengths. So we can zoom in now to see the plot. You can see on the left hand side is the differential number of interactions compared the LS group to the NL group. And then on the right hand side is the differential interaction strengths between LS and the NL group. Okay, I'm going to stop for today's tutorial. In summary, I used the bar chart to compare the information flow between NL and the LS group. I used the bar chart to compare the total number and the interaction strengths between NL and the LS group. I also used the scatter plot and the circle plot to show you how to compare the difference between LS and the NL group. I will show you how to use the heat map, the bubble plot, and also the volume plot in my next video. So I hope to see you in my next video tutorial. Please share my video to your friends and also leave comments in my channel if you have any questions. Thank you and see you next time.